Given any square matrix with the term minor, we refer to the determinant of any submatrix, of course a square one, that can be extracted from A. In particular, first minors are very important, that is, the determinant of the submatrices that I might obtain from A, removing one only row and one only column. We have introduced a specific notation for the submatrix obtained from A, removing the ith row and the jth column. We were denoting it by capital A ij. If small a ij is the element where such rows and column cross, I will call minor associated to aij the first minor associated to it, that is, the determinant of the matrix capital Aij. And the other fundamental ingredient is the cofactor of Aij. The cofactor is equal to the first minor, except maybe for a change in sign. It corresponds to the first minor multiplied by the coefficient minus 1 power I plus j. Therefore, if I plus j is even, this coefficient will give simply a plus 1. If I plus j is odd, the coefficient is equivalent to multiplying by minus 1, then correspond to a change in sign. More precisely, in the so-called even position, the first minor and the cofactor coincide. In the odd positions, the cofactor is obtained multiplying by minus 1 the first minor. Now, I'm already able to introduce the recursive formula for the calculation of the determinant. We select the first row of the matrix A and add the products of the element of that row times the respective cofactors. This is the determinant. Then we will take A11, A12 up to the element A1n, and I multiply them by the cofactors, that is minus 1 power 1 plus 1 times the determinant of A11, the cofactor of the first element, plus minus 1 power 1 plus 2 times the determinant of the submatrix A12 up to minus 1 power 1 plus n times the determinant of the submatrix A1n. Alternatively, I can add and then remove and then add and then remove the product of the entries of the row times their first minors. This is the definition of determinant. Remember it. As you can see, it's a recursive definition. I mean that it calculates the determinant using the determinant calculated for a smaller matrix. And I have given it referring to the first row. This actually is not essential.